Today we'll be talking about parallel lines and angle relationships. So in the figure below, L is parallel to M, that's the symbol for parallel, and T is a transversal. A transversal is a line that crosses two or more other lines. So when we talk about a transversal, it's the line that crosses the other lines. So when we have lines intersected by a transversal, whether they're parallel or not, these angles exist. But these two happen to be parallel, and the way we've indicated that is with these extra little arrows. Sometimes they'll appear as little triangles on them, but when you see these markings, you know that those lines are parallel. So we have what's called the alternate interior angles. So the interior angles would be the ones inside the parallel lines. So that would be 3, 4, 5, and 6. The exterior angles would be 1, 2, 7, and 8, the ones that are outside of the parallel lines. So alternate interior means they're interior, but they're on opposite sides of the transversal. So we have our interior angles. Alternate interior would be angle 3 and angle 6. Those are alternate interior, angle 4 and angle 5. So notice one's on the right side, one's on the left side. Corresponding angles. Now corresponding angles, I forgot to tell you something about alternate interior. Alternate interior angles make a Z shape. So if I trace angle 3 and angle 6, you'll see there's a Z shape there. That Z is going to come in handy for a lot of what we do in geometry for the rest of the year. So alternate interior angles, remember, they make a Z shape. Corresponding angles. Corresponding angles are going to basically be in the same location on a different line. So for example, angle 1 is on top of line and it's to the left of the transversal. So I come down here to line L. Which angle is on top but on the left? That'd be angle 5. So angle 1 and angle 5 are called corresponding angles. Angle 2 and angle 6 on the top but on the right-hand side. Then angle 3, it's on the left on the bottom, so that corresponds to angle 7. And then we have angle 4 with angle 8. Those are the corresponding angles. They're in the same location, just on a different line. Same side interior angles. We also call those consecutive. So alternate interior were 3 and 6. They were on opposite sides. These are the angles that are on the same side. So that's 3 and 5. Angle 3 and angle 5 are same side interior. Sometimes we call those SSI for short. Same side interior. And angle 4 and angle 6 also meet that description. Then we have our alternate exterior angles. So remember we said exterior was 1, 2, 7, and 8. So alternate exterior would be angle 1 and other side of the transversal, angle 8. Angle 1 and angle 8. Angle 2 on the right-hand side, angle 7 on the left-hand side. So those are our special pairs of angles, just the definitions of them. Now we have some theorems that accompany. If the lines are indeed parallel, we have some theorems that say the alternate interior angles, if the lines are parallel, the alternate interior angles are congruent. So all of these rules start with if the lines are parallel. The alternate interior angles are congruent. And you can call that the alternate interior angle theorem. The corresponding angle postulate says if the lines are parallel, the corresponding angles are congruent. And they will kind of look like it. Angle 1 and angle 5, they look like they're the same. The same side interior, this is the one that's different. If you took angle 3 and angle 5, they would not be congruent, but they are supplementary. So same side interior are supplementary. I like to remember that because of all the S's. Same side interior, supplementary. The alternate exterior angles. So if you take angle 1 and angle 8, those are congruent. Alternate exterior angles are congruent. So, oops, I forgot to finish my word, supplementary. So notice all of the pairs were congruent except for same side interior. Let's put that into practice. We'll start with this simple example. So on this one, find the measures of the missing angles. I know this angle is 50. So I'm going to start out with this piece down here. 50 and angle 7 are vertical angles. So angle 7 must also be 50. Now 50 and angle 5 form a linear pair. So 180 minus 50 is 130. And then I could do vertical angles again with angle 8 and also say 130. So that takes care of this set of angles at the bottom. If the lines are parallel, this set of angles has the exact same relationships. So we could say this 50 with angle 2, those are corresponding. So angle 2 must be 50. And then you could do this all over again. Vertical angles must be 50. And then linear pair, this must be 130 and 130. So sometimes I do a little thing called the circles in the boxes. So if I circle all of the angles that are going the same direction, those are vertical, they're the same. Those are vertical, they're the same. And then if I put a box around the others, I know that everything with a box is the same. So circle equals circles. The boxes equal the boxes. And guess what happens if I put a circle and a box together? Any circle with any box, they're going to add up to 180. So your angles in your parallel lines, they're either congruent or supplementary. All right, number 2 takes it a step further. So this one, we've said that this angle down here is congruent to angle 1. And then we've got parallel lines. So I know if my parallel lines are cut by a transversal. Sometimes when you have a lot of lines in the picture, I just recommend drawing your parallel lines and one transversal at a time. And let's just focus on this side over here. Well, what do you know about angle 4 and angle 1? They are corresponding. So angle 4 has the same measure as angle 1. Well, didn't angle 1 have a measure congruent, see the marking, to 2x plus 3? So angle 4 must be 2x plus 3 also. And then if I look at these two, angle 4 and the one next to it, those make a linear pair. So these two add up to 180. So let's add them together. 2x plus 12x is 14x. 3 plus 9 is 12. So 14x plus 12 equals 180. And we grab our handy dandy calculator. 180 minus 12 is 168. 14x equals 168. And now let's divide by 14. And x is 12. And now I can go back and find all the numbered angles. So if x is 12, let's plug it in. 2 times 12 plus 3. Angle 1 is 27. Angle 4 is 27. If I plug the 12 in here, 12 times 12 plus 9 is 153. So now if I come over here to this side, this angle and angle 2 would qualify as same side interior. So if this angle is 27, angle 2 must be 153. And then angle 3 and this angle down here are corresponding. So you could say angle 3 is 27. You could have also used the linear pair with angle 2 and angle 3 to get 153 and 27. Now we're stuck with angle 5. Angle 5 has nothing to do with my parallel lines. But if you notice, angle 5 is part of this large triangle. I already identified these two angles at the bottom as 27 and 27. So can we find angle 5? I hope so. I'm going to add 27 plus 27, and then I'm going to subtract that from 180. So angle 5 is 126. Don't worry about the fact that it's not drawn to scale. We're just answering the numbers they gave us. All right, one more. This one looks like fun. So in this picture, I've given you two expressions for the angles. Now remember, with parallel lines, they're either congruent or supplementary. So we've got to determine which these are. So I'm going to do my little circles. If I do that, I notice, hey, they're both circles. So these must be equal to each other. So I'm going to set 10x squared plus 15x plus 12 equal to 4x squared plus 40x plus 1. And now, because this is a quadratic equation, do you remember our strategy? We're going to make it one side equal 0, and then we're going to factor what's left. So subtract 4x squared, subtract 40x. If you're not sure, 15 minus 40 should give us negative 25. And subtract 1. All right, so this is going to be a challenging one to factor. We've got 6x squared and then 11. So I know in the back I need 11 times 1. I'm just going to write that, 11 times 1. And because of the signs, I know it's minus 11 and minus 1. So I've got to figure out what to do with the 6. Am I going to do 6 times 1 or 2 times 3? I just decided to do 2 times 3 because 2 times 11 is 22, and 3 times 1 is 3, and that would add up to 25. So I'm going to put 3x minus 11 and 2x minus 1. When we check our inner and outer, this is negative 22, and this is negative 3. And that adds up to negative 25. So my answers set each one equal to 0. What makes 3x minus 11 equal 0? 11 over 3. What makes 2x minus 1 equal to 0? 1/2. Well, those are lovely numbers, so I'm glad I have my calculator. I'm going to plug these back in and just double check, make sure. I think everything's going to work, but I'm going to check. So I have a shortcut to this if you're interested. I'm going to go to y1 and I'm going to type in 10x squared plus 15x plus 12. And then in this one, I'm going to type 4x squared plus 40x plus 1. Okay, so here's my little shortcut. I'm going to tell the calculator to plug this number in for me. So the way I do that is I'm going to go alpha zoom and y1. So that was alpha zoom. And whatever I put in this parentheses behind y1, the calculator is going to plug into the equation I just entered for me. So that's what I get. Wait a minute. Can this angle be 201 degrees? I don't think so. Well, let's just check and see if I would get the same answer. Whoops, plugging that into y2. Alpha zoom y2. I'm going to plug in 11 over 3. Got the same answer, so that's good, but this angle cannot be 200 degrees, so 11 over 3 doesn't work. Let's try the same thing. I'm sorry, I said alpha zoom, alpha trace, guys, alpha trace. You saw me push the button. I just said the wrong thing. Okay, if I plug in 1/2, this angle is 22. Again, don't worry about the scale. I'm going to try it alpha trace. Go to y2. Plug in 1/2. And I also get 22. All right, so 1/2 works. 11 over 3 didn't work because that angle can't be 200 degrees. So good luck.